Hey everybody, it is Mr. Reinhardt again. We've got a new lesson for this week, and so here is the video that will help you with solving all this kind of stuff. So we're going to continue on the topic of radicals, and this week we are morphing into specifically how we are going to do operations with radicals, as you can see in the title up there. Hopefully last week's wasn't too crazy for you. And this week, it shouldn't be too bad. We just need to understand a few things, but I think you're going to be just fine. So we're going to start with the easy stuff, and that's when we have like radicals. Okay, so let's go ahead and get an example here. Now, notice this one doesn't have any radicals in it, right? So that's okay. We're going to practice without radicals because it's going to look identical to this. This one is just variables, right? 3x plus 4x minus 2x. If we notice, these are all like variables, yes, like terms. So we can add and subtract these. And so the way that we would do that is just simply do it. 3 plus 4 minus 2. Okay, we get our answer, 5x. Not too hard, pretty basic. Now, what if we looked at the exact same type of problem, but instead of the x, we had root 5. Okay, so it looks almost identical except for that, but we notice that all of the radicals are the same. This idea of like radicals, well, think of it the same way as you do with the variables. These are all the same radical here. So can we add these together? Yes, we can. When they have the same radical symbol, we can do that. So this one would look like 5 root x. So again, identical to what we see up here. Okay, so now let's take a look at this one. Do we have all like radicals here? We have 6 root 7 minus 2 root 7 minus root 3 plus 4 root 3. So obviously they are not the same. Okay, we have a couple pairs that are the same. Notice this one's the same, so can we combine those two? Yeah, we can. So let's go ahead and do that. We're going to combine the 6 root 7 minus 2 root 7. That gives us the 4 root 7, and then we can combine this over here. Notice that this is negative root 3 plus 4 root 3. So this is like a negative 1. Remember, pretend there's a 1 in here. So it'd be like negative 1 plus 4. Well, that's going to be positive 3, right? So don't forget how that works, which is why that's a plus symbol. Okay, so this would be our answer because we cannot simplify it any further. We cannot combine those two because they are unlike radicals, and these ones can't be simplified. So that one's done. If we were to look at this one in the same way that we did up here without the radicals and just put the variables in there, it would be like the first two have x and the last two have y, and it would solve out exactly the same way. Okay, so hopefully that makes sense to you guys. Okay, what if they are unlike radicals? What can we do? Well, this is where it just gets a little bit harder, but it's what you already know how to do. This is where we're going to simplify. Okay, so let's take a look at these ones. We can simplify these. Hopefully you guys are thinking ahead a little bit here. We've talked about thinking ahead, that you can see what's inside the radical, and you can say, I can simplify this. Okay, 27, 48, 20. So that's what we want to do first. We want to simplify because right now, I can't just add 4 plus 2 or 4 minus 2 plus 2 because these radicals are not like. So let's figure out a way if we can get them to like radicals. Well, let's simplify them down as far as they go and then determine that. So the first one here, 4 root 27. Well, 27 is divisible by 3, which gives us 9, and then 9 is 3 times 3. So there we have the simplified version of that one. Let's do the same thing with 48. So we would go 48 on the inside, would divide it by 2 first. So that would give us 24. 24 divided by 2 would give us 12, or we could divide by 3, and then we end up with a 2 and a 2 there. However you want to do the simplification is fine with me. Just whatever makes sense for you guys, okay? And then the last one, the 20 divided by 2 gives you 10, and then 10 divided by 2 is 2 and 5. So this is just the simplified version of these ones, okay? So now that we have that, let's start doing what we did last week. Let's pull out the pairs that we can, right? This 3 times 3, well, this would be 9, so the square root of 9 is 3. So we can pull out a 3 in that one. And we have a pair of 2's right here, and then a pair of 2's right here for this radical, and then a pair of 2's in that one for the other one. So it would simplify down to that. Okay, now what you notice is that when we simplified this radical and this one, what did we end up with? These are the same, so therefore these ones can be operated on. We can do 12 minus 8 because they are like radicals. This one over here still can't because it's got a root 5 there. Okay, so there is our answer. 4 root 3, because that's 12 minus 8, And then the 4 root 5 just stays the same. Okay, the thing to remember here is that you want to simplify first. All right, so when you get to stuff like this, simplify it down just like you would fractions. Okay, simplify those first, then try and start doing the operations on them. Okay, so let's do another example here. 6 root 50 plus 3 root 32 minus root 48. Okay, let's start simplifying these ones down. Go ahead and hit pause, simplify those, and then when you're done simplifying, come back up because I'm just going to bip, bop, bip right there. Okay, that's what yours should look like. Root 50 should simplify down to this because 2 times 25, and then 25 is 5 times 5. Same thing right over here. Okay, again, you can pause the video and do the simplification, and then when you're ready, you can go ahead and move forward with it. Okay, now that we've got that, let's start getting the pairs. Bip, bop, bip, bop, bip. Okay, once you've got those pairs, start extracting them, right? This pair of 5s can move out. Pair of 2s, pair of 2s, pair of 2s, pair of 2s. Okay, get those out of there. So now we have these simplified versions of each of the radicals. And do we notice if any of these are now like radicals? Well, yeah, we got the first 2 are like radicals. So go ahead and put those together. And there's your answer. Okay. Again, it's going quick, but just hit the pause button, right? If you're confused, hit pause, hit rewind, whatever you need to do. But this is what we end up with. And this is a perfectly acceptable simplified answer. Okay, we cannot go any further. Just like if this said 42x minus 4y or 42b minus 4c, it doesn't really matter what they are. If, you know, it's simplified. That's the way that it goes. Okay. All right, so let's go to this one here. It's got the fractions. Okay, we want to simplify first. Remember, don't freak out. Let's just simplify first. So let's take the 14. What would that simplify to? Hopefully the answer that you came up with was 2 and 7. And then this one here, if we've forgotten, typically this is one that we forget. If it's a fraction inside of the radical, you would just separate it out towards the radical of the top over the radical of the bottom, okay? So now that we have this, what we really want to start doing is we want to get rid of the radicals on the bottom. If you remember from last week, there was a rule where we can't have the radicals on the bottom. So how do we get rid of it? We multiply by 1s, and remember, it doesn't matter how that 1 looks. We just want to make it work for this problem. So 1 can be 1 over 1, 2 over 2, 3 over 3, or radical root 7 over root 7, right? Because that would help get rid of this as having a radical on the bottom. Again, we're just multiplying it by 1, so it doesn't change the value. It just makes it into a form that we can use. So now we have this. And if you notice the 2 and 7 here, because those are prime numbers and we can't pull anything out, we don't need to. So it just goes right back to the root 7 or root 14. So if you figured that out way back over here, totally fine. But we tried to simplify it. It doesn't simplify any further, so it just stays the root 14. And then now if you notice, this mess over here turned into this. Okay, so when we go root 7 times root 7, remember that becomes 7. Okay, and then up here, root 2 times root 7 becomes root 14. So now, how can we combine these? Well, when we combine fractions, what do we need to have? We need to have a common denominator. It doesn't matter that the tops are the same. Don't get confused. We want a common denominator. So that means that we need to have a denominator over here that is equal to 7. Remember, what's under here, even though we can't see it? Yes, it's a 1. So if we want to change this over here to have a common denominator, then we want to multiply it by 7. So let's look at what happens here. If I'm taking this right here and I multiply it by 7 over 7, okay, that would give me a denominator of 7, and I just have to put the 7 on the front up there at the top, okay? And then this one just moves over here, okay? And so now we can combine these because we have a 7 on the bottom. It's a common denominator, and so therefore we get 8 root 14 over 7. The very last step that you would do is determine if this can be simplified, okay? And if this cannot, then you're good. So can you reduce 8 over 7? Can you divide them both by the same number? Nope, it's already simplified, so there's your answer. All right, here's the next one. Let's do it again. Hit pause, go and solve it out, and then when you're done, hit play again, and we will you'll see the answer here. Okay, so hit pause right now. All right, so we're back. We have simplified this first one here, root 32, 2 times 2 times 2 times 2 times 2. Okay, kind of nice. Any computer geeks should understand that a little bit. And then the root 1/2 becomes root 1 over root 2. Got it? Okay. We only want to simplify this or get the root out off the bottom of this one. We can pull some pairs out of here, right? We got a pair here, and then a single there. So the reason why we've got this is to get rid of the root on the bottom here. So what's going to happen after we do this? This one here, we pulled out a root or a pair of 2s and a pair of 2s. So that's where that came from. And we're left with a single there. And then this one right here, root 2 times root 2 on the bottom turns into 2. And then on the top, root 1 times root 2, it's just simply root 2. And then we need these two terms here to have the same denominator. Okay, so we take the first one, whichever one we need to, and we make it with the right denominator. So that means we're going to have to multiply it by 2. Oh, I pressed too many buttons there. Oh, no, I guess I didn't. It's just both of them. So this one here, we multiply the top and the bottom by 2. So 2 times 4 is 8, and 2 times 2 is 2. Now we have a common denominator. Solve it out. This is an 8 plus a 1. Don't forget there's a 1 there. And then the 2 stays the same. Again, last thing is, can I reduce it? No, I cannot. So this one is done. Okay. Oh, man, now we're getting somewhere. All right, next one here. This is, what do you guys think we need to worry about here? What is the, I'm going to spoiler alert and say property that we need to use here? We need to use the distributive property. Good. The distributive property. So that means that we're going to have root 5 times this and times that. Okay. So let's do distribution. And I don't know why I said that weird. So root 5 times root 15, we get this. Root 5 times 3 root 10 just turns into this. Okay. See the previous lesson on how that works. When you just multiply this times this one, it's not root 5 times 3. Remember, this is a single term here. 3 times 10 is a single term. 3 times root 10. So the root 5 just goes in the root there. Okay? Now that we have that, let's simplify if we can. I can simplify this 15. This goes into 3 and 5. And the 10 goes into 2 and 5. Okay? So you see what I did there. Now, if you notice, we have some pairs, don't we? I have a pair of 5s here, and I have a pair of 5s there. Okay, so if I have the pair of 5s, this would come outside, leaving me with 5 root 3. And the pair of 5s here comes outside, so it's going to be multiplied by that negative 3. So then it's negative 15 root 2. Okay, and then you just ask yourself, can I keep going? Can I add or subtract these together? No, I can't, because they are not like radicals. Okay, just a couple more examples for you. This one here, we got a binomial and a binomial. Okay, what do we do with those? Do you remember the method? FOIL method. Yeah, it's going to be the firsts, which are these two. The outers, which is this one and this one. The inners, which is this one and this one. And then the last, which is this one and this one. Okay, so that's the FOIL method. So let's go and do that. 3 root 2 times 5 root 3. Bip, bop, bip, bop, bip, bop, bip. It's a lot of stuff that we're adding in there. And sorry about that, but it's just the way that it goes. 3 root 2 times 5 root 3. That's this one. Okay, 3 root 2 times negative root 10. That would be this one, and I've already simplified it. Okay, that 10 on the inside would simplify down. So this would be 3 on the outside, and then 2 times 10 on the inside, and it simplifies there. Just double check your math there. And then the inners would be root 5 times 5 root 3, right here. And then last is root 5 times root 10, so that's what we get there. Okay, notice that I've already factored it. Oops, I didn't factor this one. But why not? It's because it can't factor anymore, right? This would become 3 times 5. Does that help me? No. Same thing over here. 6 would become 2 times 3. Does that help me? No, it doesn't. Okay, so that's why I didn't factor those two. But these ones are because I can pull something out of it. So that stays the same. The next one, I pull out the 2's and it goes in front here. So 3 times 2 is 6. This one here stays the same. And then this one, I pull out the 5. So it's 1 times 5. Okay, and then combine anything you can. So the question is, can you combine anything in there? Is there anything left to combine? No, there's not, because this is a root 6, root 5, root 15, root 2. None of them are like radicals, therefore they cannot be combined. Okay, last one coming here, and we're going to be done shortly with the video. So this one here is a square of a binomial that has a radical in it. So if it helps you, write it out. Okay, 6 plus root 3 in parentheses times 6 plus root 3 in parentheses there, if that helps you out. Or if you can just remember the process, you square the first, you square the last, you multiply the middles and double it. If you remember that, then do that, okay? So here's how it looks. Square the first, square the last, multiply those two middles and double it. So if we go the first one, it's going to be 6 squared. Done. Then the second part would be this squaring the last. So root 3 squared right there. And then you multiply the two middles. So this would be 6 times root 3 and then double it. So it's 6 times root 3 and then double it. Okay, so we get 36 for that one. 2 times 6 is 12. And then root 3 squared, right? That's just 3. Don't forget what that looks like. Okay, this could be a nice shortcut for you if you realize what you're looking at here. It just turns into something real nice. And then combine what you can, right? 36 and 3 can combine. Okay, so we get 39. But can I combine the 12 root 3? No, I can't. That's it. Okay, so again, take the time, go back, pause the video and the section that you need to do. When you're doing the homework and you see any of these that you're confused on, come back to the video, watch it, pause it, rewind it, that sort of stuff. Don't forget you can email me, see me during my office hours, phone call, anything like that. Okay, good luck. Don't worry about Redbook, $5.95. I'll have a CUDA software assignment for you guys. So if you can do it digitally, great. And if you need to print it out and do it by hand, that's totally fine too. We will talk to you later.